Hi, I'm Matt Clapham, a tester with the Rights Management Server team here at Microsoft. We make rights management server products, and I specifically test our cloud deployment technologies. I'm here to talk to you today about securely testing your products. I'm here to talk to you today about my top 10 tips for securely testing your products. Let's start off with our agenda. We're going to talk about some vocabulary. We're going to go over my 10 tips, and then we'll talk a little bit about what testers should do. First, let's go over some vocab. You ever heard of a buffer overrun? Those are one of the most common security testing problems that we have in the industry today. We're also going to talk a bit about ACLs, access control lists, and authentication, authorization, encryption, and various other technologies of that sort. And we'll touch briefly on the STRIDE model from Michael Howard's book. First tip of all, don't run your tests as admin. I cannot stress this enough. It is so important that we test as users, not as administrators. You will find numerous problems in your product if you just take away the administrative rights of the currently logged on user and run your program. If you do need some secondary access to be able to get to, say, an administrative situation, you can use the run as functionality built into Windows 2000 and Windows XP, and you can also perhaps have a secondary logon to the domain to be able to have both administrative and non-administrative roles. You'll definitely see applications that are going to try to do stuff that they're not supposed to, such as opening the class ID registry keys for read-write when it's only allowed to have read. Second tip, test on a secure file system. Again, this is so important that you use NTFS for the operating system drive as well as the drive where the program is installed on. Be wary though, if you take a FAT system and upgrade it to NTFS, you may not get the permissions appropriately. You can also, after the fact, test on other file systems as you might need to, such as FAT32, FAT16. The key factor here is to start with the principle of least privilege. Start with the bare minimum rights that you need, read-only, lockdown specifically, and then add them as necessary and as is appropriate for the application that you're testing. Another tip, turn on disk quotas. It's amazing how quickly you can find your application fails if it can't write to the disk because it's not allowed to use any more space. Another good idea is to see how your application can save its data into a Dropbox. You're all familiar with those comment cards that you place in at a restaurant or at a store. Imagine if you set up a folder that does exactly that, where you can drop stuff in but you can't see what's inside. Another thing, cardinal sin that a lot of programs do is try to change Hive key local machine in the registry or something under the program files directory. These are big no-nos. The average user does not have rights to change anything in those registry or folder locations. Again, harkens back to don't test as admin. There are various tools that will help you find this. One of the best that we have right here at Microsoft is the Windows Application Compatibility Toolkit version 3.0. This is a great tool for wrapping around your application and finding some of these problems that I've popped up. You also might check sysinternals.com. They have some nice little tools called FileMon and Regmon that'll let you watch what your application is doing with files and registry entries. Bear in mind where your application is trying to store its data because it may or may not be the appropriate place based on the Design for Windows guidelines. Remember, not all users can write their program files, and the best place to store user data is in a Hive key current user, somewhere under their user profile or in the application data folder. Another key thing, don't store or send secrets in clear text. If it's really a secret thing, use some sort of encryption. And better yet, only store it if it's absolutely necessary. Further still, don't store the secret, store a hash of the secret. Much like the way we store passwords today in Active Directory and in the Security Accounts Manager. Try to use some sort of randomization factor on your crypto so that it's not easily reverse engineered. Use the crypto APIs. We supply a whole API set that's just perfect for handling all these sort of secure transactional issues. Know where your network trust boundary is. This is so important, that you know where can you trust data will not be sniffed and where do you have to be weary about it. And at that point, make sure that you understand the legal concerns, such as the Health Information Privacy Protection Act and various other legal privacy acts around the world. I know a lot of people will tell me that I'm sort of not in touch with reality here, but you need to get adequate feature documentation. It doesn't have to be perfect, but it needs to be adequate. It is so important that you know the 5 W's: who, what, where, when, and why, for all the features that you're working on. It doesn't have to be very in-depth knowledge, but you need to know those details. You need to know what registry keys the feature is using or the application is using. You need to know the DLLs that are involved. You need to know where the support and temporary files are stored and what permissions are on those. And if it's an XML data transaction, you need to know the XML schema, the data types, and the sizes. Similarly, if it's binary data, see if you can get some debug hooks that will let you look inside of the data structures and understand more about them and be able to look in and get back out those other details you're looking for. Also, find out if the feature is on by default. When you're testing, press the limits of bad data. This is very important to understand where the application is prone to crash or to have one of those buffer overruns that we talked about earlier. Look for blatantly wrong data, such as just totally random data files. Partially wrong, where you're deliberately changing 1 or 2 fields. Perhaps using a different format for date or time. Try oversized if it's only expecting, say, a 256 character buffer. What happens when you put in 257? Look for off by 1 bugs. Is it expecting 0 to be the first number or 1? And try changing bad fields 1 at a time and several at a time in unique combinations. Test on dual processor systems is my 7th tip. It's really useful and very helpful for finding things like multi-threaded race condition bugs. And it's widely available today. Pretty much every tester and developer should have at least one system in his office that is capable of dual processor. Some workstations from various computer providers can be made into a dual processor workstation, because all you need to do is add a second proc to the proc that's there. And anything from Windows NT 4 and higher will support it. Also, remember some things that we just recently started having. Intel's Pentium 4 technology with hyperthreading functions enough like a dual processor machine that it can help you find some of those race conditions I mentioned. Know the 20 laws of security. We have the 10 laws of security and the 10 laws of security administration that were published on Microsoft's security website last year or the year before. Remember the caveat to the first law, though, that you want to focus on last man standing and defense in depth. Even though you could say, well, it doesn't matter, if the user can do something really bad on their machine, then all bets are off. Yeah, but that user shouldn't be able to prevent or to create bad things happening for other users on the machine. Secure your test systems. Again, very useful. Make sure you're up on the latest patches, fixes, service packs for all the software in your test environment. And you can use Microsoft Baseline Security Analyzer version 1.1 to help you make sure that you have all the patches, the latest and greatest from Microsoft. Use various tools. Again, I mentioned earlier the Windows Application Compatibility Toolkit. There are various port scanning tools if you're dealing with some sort of network feature or program. We have another tool called Network Monitor that is available as part of Systems Management Server and also shipped with Windows 2000. That'll let you monitor network traffic. Again, there's the Microsoft Baseline Security Analyzer, and various other third parties can provide little tools that just make your job of trying to figure out if your application is well behaved that much easier. Finally, analyze the source code. There are some functions that we have deemed in writing secure code as suspect and to be wary of. And so use your favorite code scanning tool to walk through your code base and see if some of those functions are there. They're all listed in Appendix A of Writing Secure Code 2nd edition, and it'd be really easy to whip up something to look for all those and then go through on a case-by-case basis and see if that potentially needs to be changed to a safer alternative. If you're a tester, attend the code reviews. Even if you don't understand how to write code specifically or how the code of that function or feature or program works, you'll learn some insight into data structures and where you might find potential bugs that can help you in making a better product. Send your list of findings to the developer just so that he has a heads up to say, hey, I just found all these spots in the source code where we might have to change some of these functions. What do you think about them? Do you think this is okay? Do we need to change them all right away, or can we work around them? So let me recap here. Number 1, don't test as admin. Number 2, test on a secure file system. Number 3, don't change Hive key local machine or program files. 4, don't store secrets as clear text. 5, get adequate feature documentation. 6, press the limits of bad data. 7, test on a dual processor system. 8, know the 20 laws of security. 9, use the various tools at your disposal. And 10, analyze the source code. So, finally, to wrap things up, here's what each tester should do to help make sure they are securely testing their applications. Use a security section of your test plan to describe to program management and development and operations how you plan to test and test securely. Make sure that you have some security-specific test cases that use the various tools or harken back to the 10 tips I've already mentioned. Make sure that you're running feature-specific security tests. Have a variety of people in to look at just the security portion of your test plan and just the security portion of your test cases. Understand the security risks for your feature. What are you trying to protect? What are you trying to keep safe? What's the baddest thing that could happen if that information was leaked, and how do you keep it? Bear in mind that this also has great benefits for integration and robustness testing. If your feature is well secure and can handle some of those top 10 tips like a dual processor system, then it's going to probably be a very robust, durable feature and will really work well. Make sure that you participate in security reviews looking for your features or the part of the application that you have. That'll let you learn the inside details that you need to be able to execute on the security portion of your test cases and test plans. So, in summary, we've gone over vocabulary, we've gone over my top 10 tips, and we've gone over what's expected from each tester to securely test their applications. I'm Matthew Clapham. Thank you very much.